Hi, everyone. I wanted to start by mentioning, firstly, why both Sammy and I weren't able to attend the presentation. Unfortunately, the last few weeks have been trying for both of us. I personally found myself stuck in the UK over the holidays and managed to come back before New Year's, only to find out a few days ago that I was corona positive. Therefore, at the moment, I'm quarantining for the upcoming week. Sammy, on the other hand, is not able to attend for other reasons. At the moment, he's stuck in Germany, not being able to return as a result of the new Dutch regulations, requiring him to have uh, a recent negative PCR test for travel eligibility. He has been trying to reserve a test, but cannot find any available slots to actually book one. For this reason, either of us can be there physically, and we wanted to mention this and apologize for it as neither of us could have actually anticipated it. Now let's go into why we chose this idea and why we went with this idea for our system. Um, Other studies have been trying to make associations between negative emotions and non-biased auditory stimuli. Both of them are obviously hard to interpret and quite subjective. Our project aimed to offer users a safe platform they could utilize to express their feelings through a wide range of synthesized sounds. After researching this subject thoroughly, we came to the conclusion that an appropriate solution for this was to use a neural audio synthesizers and computer-aided music generation tools. The system we constructed serves as a reliable and accessible interactive system, able to assess users' negative emotional states in real time. The target audience for our system are individuals diagnosed with depression or alexithymia. People experiencing such conditions usually are more reluctant and not always comfortable in addressing their emotions or cognitive struggles verbally. In terms of functionalities, our system makes use of the following: Google Magenta Studio, Ableton Live, Max for Live's connection kit, and an external touchscreen display we used for input and recording of the data. The system was initially supposed to be installed in the ACI lab, restricting the amount of light from the test room to establish an immersive connection between the system, environment, and its participants. As a result of the recent COVID regulations, we did not have access to either monitor speakers or a room to install our system in. For this reason, we decided to purposefully blindfold our users to mimic the immersive effects of dark rooms. And we actually substituted the speakers with high quality studio headphones. The users the user is briefly informed beforehand of the touchscreen display features and what to expect from the experience. The X and Y values of the touchscreen are translated to MIDI data using the Max for Life software. Afterwards, input data to control is assigned to specific features of Ableton Live using a neural synthesizer provided actually by Ableton Live. Allow me just 2 seconds to share my screen. Yeah. In the first screenshot, it is represented the Max for Live and Synth interface along with its features. While in the second one, while in the second screenshot, you can see the X and Y axis grid. E Instruments are positioned at each of the corners of this grid. Users will start from the middle point, and are free to explore as they want. This allows the users to mix among all four if they desire to do so. We tiled some of these four instruments grids next to each other, which ultimately created a multi-grid. The polished interface allows you to explore up to 64 different instruments by dragging across a single X and Y touchpad. Mixing between the four of the nearest instruments allows users to explore the space of NSYNC intuitively. The MIDI file of Prelude for the Afternoon of Faun by Claude Debussy starts playing when the user begins interacting with the system. The MIDI file is responsible for generating notes, not the actual sounds. As for the sounds, the system uses a neural synthesizer that can be seen in this last screenshot here within the Ableton Live scene. Um, NSYNC permits the system to use a variety of sound choices. our system represents a fresh approach to assessing relationships between the auditory stimuli and emotional response. Users are able to generate sounds and assess their emotional states simultaneously. We decided not to include any visual stimuli after examining the pre-test results. Based on our participants' opinion, it would have represented an unnecessary distraction from the experience itself. Now that I have described the intentions and functionalities of the system, Sammy will take over and talk about the user evaluations and future work. Thank you.
As Tudor explained earlier, our research objective was to see if this interactive user interface can be used as an assessment tool for emotional recognition, especially with the focus on basic negative emotions. We are aware of a number of studies that have done previously by mainly neuroscientists and psychologists that have tried to answer an interesting question: how one's emotional state can be affected by music and, by more general term, the auditory stimuli. When we were reading those studies, we found out about something really interesting. Many of these studies were mostly focused on finding the relationship between listening to different pieces of music and the neural processing of emotional states inside our brains. But since the beginning of our research, we intended to determine an efficient tool only for negative emotional recognition. Those studies shows us that from a neurobiological perspective, various emotions in music are responsible for triggering different areas of our brain. As for the user evaluation, we done that in three different phases. For the pretest, the result demonstrated that presenting people with auditory and visual stimuli at the same time can potentially lead to confusion and discouragement in terms of identifying emotions. Secondly, the pretest showed that the music piece we chosen to use for our product is well suited for our purpose. Users presume that they can identify their negative and dark emotions according to this musical piece. Therefore, we decided to continue our research with the second version of the product, the neural network based synthesizer, which doesn't make any use of the visual stimuli, and the system's immersion is solely based on the sound. And when the final product was ready, we asked them to fill out a questionnaire to evaluate our user psychological reactions to our product after they interacted with it for like 3 minutes. Our intention for that phase of user evaluation was to find out if we can establish a clear connection between different synthesized sound and the four basic emotions we were investigating in our research. But interestingly enough, less than 10% of them describe their emotional states using basic emotions. The majority of our users described complex emotional states such as feeling nostalgic, overwhelmed, or aroused. They even showed some expressive behaviors like tear and shiver and goosebumps. However, our users could somehow link how they were feeling to a relatable sound. Our system was able to act as as an emotional recognition tool, but not in a way that we first intended to do. In response to our product attempting to determine their feelings, the user evaluation result indicated that most people experience a more range of complex emotions. As for the usability requirements, our system works as intended in terms of both satisfaction and efficiency. They were able to perform various tasks precisely within our system without any kind of interference. We tried our best to keep the user interface as simple as possible, so learnability was not an issue. And after providing them with an overall overview of our system, users could learn how to interact with it very easily. I should also mention that rating our product in terms of percentage of goals achieved and error tolerance was difficult for participants. I think this effect is understandable considering that the users who managed to describe their emotional states were more satisfied compared to those who were just experimenting with the system. Also, I should mention that our research was one of the first of its kind to use a complex neural based audio synthesizer as an audio generation tool for emotional recognition. We are aware that the sound quality of this synthesizer isn't satisfying for an audiophile audience. But since the neural audio synthesizers for musical notes is relatively a new audio synthesizers method and WaveNet decoder is computationally expensive, there's a plenty of room for improving the sound quality in the future. Another aspect of this research, which we could improve in the future, is the criteria for choosing users who perform the evaluation. We think that experimenting with different users and determine how they react and describe their emotional states based on their background in terms of familiarity with music and arts could be important, considering that some of our users who had a background in music and fine arts were able to describe their feelings in a much more complex and expressive manner than those without any background in this field.